Alright, let's check here. What you need to do when you do this is simply FOIL this out. In my case, I will actually use a short method where I just multiply the first term and the last term only, because these brackets are exactly identical, which means that they were a difference of two squares. However, I'm going to FOIL out here, okay? You could have just said square root of 3 times square root of 3, it'll give you 3, okay? Square root of 3 times square root of 3 is 3, and negative 2 times positive 2 will give you 4. However, if you FOIL out, it will give you this long method, okay? When brackets are exactly identical, however, the only difference is plus and minus between the terms, then you must just multiply the first terms and the last terms only. You don't need to FOIL out by multiplying the inner and the outer, right? You just multiply the first and the last, and well, the first and the first and the last and the last. That's all you have to do. If you realize that the brackets are exactly the same, the only difference are the signs that are in that bracket, and obviously it has to be opposite signs. It has to be plus in one bracket and minus in the other bracket, okay? Now in this case, you realize that this cancels with that, so you will be left with 3 minus 4. 3 minus 4 is minus 1. Classwork 2, here you had to break 8, you had to break 50, you had to break 18. Find a perfect factor for 8. A perfect factor for 8 will be 4. You're going to multiply it by 2. A perfect factor for 50 will be 25, multiplied by 2, and a perfect factor for 18 will be 9, but you're going to multiply that 9 by 2. So this is what you're going to have, all right? For me to get 2, I simply square rooted 4. The square root of 4 will be 2, and the square root of 25 there will be 5, and the square root of 9 there will be 3. Now these are like terms. All you have to do, you know your answer will have the square root of 2. You just have to add the coefficients of the root of 2. So you will simply say 2 plus 5, which is 7, and then you minus 3, it'll give you 4. So it will be 4 square root of 2. Here, all you had to do was to repeat the bracket twice. Please note that if a number is raised to an exponent of half, it is the same as though it is the square root. Now, from here, I can't apply the short method because the brackets are the same. Okay, they are exactly the same in this case with the signs as well. Remember, you can only use the short method where you multiply the first and the last if the signs are not the same. But in this case, they're exactly identical, so there's nothing you can do here. You have to use the FOIL method. And this is what you will get, okay? 8 plus 2 will be 10, and minus square root of 2, square root of 8 minus square root of 2, square root of 8 will give you minus 2 square root of 2 square root of 8. We can still simplify this. That 8 is 4 times square root of 2, and 4 times square root of 2, obviously. This is how I got it. When you find the square root of 4, it'll simply give you that 2, and inside you'll have the square root of 2. This is how we got it. But 2 times 2 will give you 4. Square root of 2 times square root of 2 will just give you 2. Hence, we have this, okay? Now you'll end up having 10 minus 8, and 10 minus 8 is 2. Here, all you have to do is just to distribute that cube root to the integer 27 and to the variable, which is x to the exponent 6. You'll do the same thing in the second term. You will distribute this by giving 32 its own fifth root and giving this x to the exponent of 10 its own fifth root. The cube root of 27 is 3. The cube root of x to the exponent 6, you just take that 6, you divide it by 3, it will be x to the exponent of 3. I mean x to the exponent of 2. The fifth root of 32 is 2, and the fifth root of x to the exponent 10, you're just going to take that 10 and divide it by 5, it will give you 2. Now you end up having x 3x squared plus 2x squared, which is simply 5x squared. Now here you're going to do the same thing that we did in the previous slide. You're going to repeat the brackets twice. If I multiply, I'm going to multiply like this. Four times 4 is 16. Square root 2 times square root 2 is square root 2 times square root 2. 3 times 4 is 12. And we still have that root, so it will be the 12 and then square root of 2. And 4 square root 2 times minus 3, it will give you 4 times minus 3 is minus 12, and we still have the square root of 2. Minus 3 times minus 3 will give you 9. Please note, when you multiply the root of the same integer or the same variable, you just cancel out the root and you just leave that integer. So square root of 2 times square root of 2 is just 2. The square roots just cancel out. In essence, as a matter of fact, it's just half plus half. So that is why that 2 should represent it as a single base. You're going to add half plus half, which is 1. But I don't want to get into that for now. We'll get into it later on. Okay? Please note, minus 12 square root of 2 minus 12 square root of 2 minus 12 minus 12, that is 24 square root of 2, and I still have that 9. 16 times 2 will give you 32, and 32 plus 9 will give you 41. That is why I still have 41 minus 24 square root 2. Here you do the same thing. Split this root, okay? So you're going to give 27 its own square root, and you're going to give this m to the exponent 6 its own square root. Here you're going to give 12 its own square root, and m to the exponent of 8 its own square root. Square root of 27 is... Now, square root of 27, one perfect factor will be 9 times 3. And I still have this m here. When you find the square root, you will just divide that 6 by 2. And it'll give you 3. Perfect factor for 12 is 4. You're going to multiply it by 3, so 4 times 3 is still 12. And the square root of 8, you're going to take that 8 and divide it by 2. 8 divided by 2 is... it is 4. Now, understand here, the square root of 9 is 3, but the square root of 3 will still be the square root of 3. Here I have m times m, it will be m to the exponent 4. The square root of 4 is 2, and I'll still have the square root of 3, m to the exponent 4. I hope you got that. Now you realize these are like terms. So I'm just going to say 3 minus 2, and it'll be 1, and I just keep that root 3m to the exponent 4. Here I'm going to find a perfect factor for 49, and I will multiply it with an integer. A perfect factor for 75 multiplied with the integer. A perfect factor for 108 and multiplied with another integer. So the perfect factor for 48 is 16. So I'll multiply it by 3 for me to get 48. A perfect factor for 75 will be 25. And I'm going to multiply it by 3. A perfect factor for 108 will be 36. and then I'm going to multiply it by 3. Please note the square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. I still have that 3 over there. I still have that 2 over there. It hasn't changed, okay? I'm going to keep everything in brackets. However, you'll realize that this 3 times 5 is 15. 2 times 6 is 12. And then you're going to say 4 minus 15 minus 12. It'll give you a positive 1. So the square root of 3 remains there. So I'm going to have 1 square root of 3. Now I still have the square root of 3 from outside the brackets. When you multiply the square root of 3 with the square root of 3, the square roots fall away. You'll be left with 3. Here, find a perfect vector for 18, which is 9, a perfect vector for 98, and a perfect vector for 100. So you'll have 9. For 98, it will be 49 multiplied by 2. And for 200, it will be 100. That is a perfect vector. You multiply it by 2. The square root of 9 is 3. The square root of 49 is 7. And the square root of 100 is 10. 3 minus 7 will give you minus 4, but it will be minus 4 square root of 2. Minus 4 square root of 2 divided by 10 square root of 2. So my answer will be minus 2 over 5. Here I find the square root of 64. Remember, it's a square root into a square root. You can write it as the fourth root of 64, which is the same thing. In this case, obviously, the square root of 64 is 8. And I can't find the square root of 12. I can't find the square root of 18. I can't find the square root of 27. For me to simplify 8, I'm going to find a perfect vector for 8. The perfect vector for 8 is 4 times 2, obviously. I'm going to multiply the perfect vector with 2. A perfect vector for 12 will be 4, but I'm going to have to multiply it with 3. A perfect vector for 18 will be 9, but I'm going to multiply it by 2. A perfect vector for 27 will be 9, but I'm going to multiply it by 3. Obviously, the square root of 4 is 2. The square root of 2 will still be a square root of 2. You just distribute the square root, okay? You give each of those factors its own square root, so you split it. The square root of 4 is 4. The square root of 3 will still be the square root of 3. The square root of the square root of 9 is 3, and the square root of 2 will still be the square root of 2. The square root of 9 here will still be 3, and the square root of 3 will still be the square root of 3. You'll realize that in the numerator you have a common factor of 2. In the denominator you have the common factor of 3. Take them out, and this is what's going to happen. So you will be left with 2 over 3. Here, FOIL out the numerator. And obviously the square root of 100 will be 10. I can't find the square root of 48. I'll have to split it by finding a perfect vector. When I FOIL out the numerator, this is what I'm going to get. 2 times 4 is 8. And 2 times negative square root of 3 will be negative 2 square root of 3. Square root of 3 times 4 will be 4 square root of 3. Square root of 3 times square root of 3. Please note that there's 2. Square root of 3 times square root of 3 will just be 3, okay? And then 4 minus 2 will be 2, so I'll be left with 2 square root of 3. 8 minus 3 is 5. For the 8, the perfect factor is 16. When you find the square root of 16, it will give you 4. In the numerator, there's nothing I can do, but in the denominator, I can take out a common factor of 2. So I will be left with 1 over 2. It's pretty much a repetition. I'm going to repeat. I'm simply repeating the same thing over and over again. Here you're going to split this cube root, give 27 its own cube root, and give this x to the exponent 6 its own square root. Give 16 its own square root and give, fourth root, and give 8 x to the exponent 8 its own fourth root. Here I'll be left with x to the exponent of 2. There I'll be left with x to the exponent of 2 as well. In the denominator, give 125 its own cube root and give 27 its own cube root. And obviously here I'll be left with 27 divided by 3, which is simply 9. In the numerator, I'm going to add 3x squared plus 2x squared. That's going to give me 5x squared. And obviously 5 goes into 5 once. When it comes to variables, check the exponents of the variable and take the lowest exponent and subtract it from the biggest exponent. So I'm gonna take this 2 and minus it from 9. By taking this 2 to the denominator, it means that in the numerator I'm just left with 1. And hence I'm going to have it'll be 9 minus 2, which is 7, and that's what I'm going to get. For this one here, I'm going to do this one and then you will do the rest. For this one here, you have 3 to the exponent of 2005, 3 to the exponent of 2006, 3 to the exponent 2007, 3 to the exponent 2005. You realize that 2005 is the lowest exponent, so make sure you express everything to the exponent of 2005. When I split this, for me to get 2005 from that, it will be 2005 plus 1. Obviously, it will be 2006. Here, I'm going to have 2005 plus 2, which is 2007. So I need to make sure that in my exponents, I have 2005. Nothing has changed. 2005 plus 1 is still 2006. 2005 plus 2, it is still 2007. So I haven't changed anything. All I did was just to split this exponent so that I have 2005. Now split it. Please note that if your exponents are added, it means that you multiply the same bases. Alright, so basically whenever I added exponents, it means I multiplied the same bases. So reverse this exponential law. When exponents are added, it means I multiply the same bases. So basically I multiply 3 to the exponent of 5 with 3 to the exponent of 1. Here it means I multiply 3 to the exponent of 5 with 3 to the exponent of 2. And I still have that. Now you realize that whenever you see plus or minus, make sure you take out a common factor, especially when it has exponents. Now in the numerator, my common factor will be 3 to the exponent of 2005. In my denominator, my exponent will be 3 to the exponent of 2005. This is what I'm going to be left with. Students have a tendency of when they take this 3 to the exponent of 2005, they just leave nothing there. Please note that when you take it out as a common factor, you're left with 1. Here is that 1. Similarly, if I take this out as a common factor, I'll be left with 1 over there. And there is that 1. Make sure that there is a number on each side of the positive or negative side, okay? Obviously, 3 to the exponent of 2005 goes into 3 to the exponent of 2005. Once in the numerator, you'll be left with 4. In the denominator, you'll be left with 8. And this will give you a half. This is your classwork. Now let us quickly rationalize the denominator. When you rationalize the denominator, it is useful to write the fraction with the rational numbers in the denominator. So you know rational numbers in the denominator are simply numbers that you can express as a fraction. Basically, when you enter it into a calculator, it can't give you a decimal. When a surd is present in a denominator, it is possible to write the denominator as a rational number by multiplying the numerator in the denominator by the surd, which is in the denominator. Okay, I will give you one example in a moment. So basically, if I have something like this, you'll realize that I have an irrational number in the denominator. So I'm going to multiply both the numerator and the denominator by that irrational number. Please note that by multiplying by square root of 3 divided by square root of 3, I'm basically changing nothing because that is just multiplying by 1. I'm just trying to get rid of my denominator. Basically, this is what we did in grade 9. We're just finding an equivalent fraction, but that equivalent fraction mustn't have the square root, which is the square root of 3, which is irrational. We're just looking for a rational number. So this is just an equivalent fraction. It's equivalent to the original fraction that we are given, okay? And this is what you will have. Square root of 3 times square root of 3 is just 3. Obviously, you will just cancel those square roots, but I told you why we normally cancel them. When you're finding the square root, multiplying the square root of the same number, actually when you're multiplying identical square roots, you just your answer will just be the square root of the number that you are multiplying the square root of. Okay, in this case it is just 3. Now let's get to the next one. Obviously 12 divided by 3 is 4, so my answer will be 4 square root 3. Here I will do the same thing. I'm just going to multiply both the numerator and the denominator by square root of 5, and this is what I'm going to get, okay? There's nothing I can do from there. Guys, please note that you may not cross out across addition or subtraction. In this case, you can't do that. Please don't do that. You only cross out if you have vectors. In this case, you don't have vectors, okay? You have 2 terms in the numerator. You don't have 1 term. You can only cancel if you only have 1 term in the numerator and the denominator, obviously. And remember, for you to have 1 term, they need to be vectors. So in this case, I'm just going to leave that like that. Here, we'll do the same thing. It's slightly different in this case. You will just have to multiply both the numerator and the denominator by the conjugate of the denominator. The conjugate is simply, you just change the sign between the terms that are given to you in the denominator. I actually prefer to write it as 2 square root 2 and then just change the sign of that square root 2, but you can still change it in this case. So I will just multiply by the same identical denominator, but I'm just going to change the sign in between the terms that are given in the denominator. So I'm going to multiply by the square root of 2 minus 2. And by doing this, you'll realize that in the denominator, you have a difference of 2 squares. You're going to multiply brackets that are exactly identical. So all you're going to do is just to multiply square root of 2 with square root of 2. It'll give you 2, and multiply 2 with minus 2. Or you can do it the way I did it. I simply used the FOIL method. Please note that 2 square root 2 minus 2 square root 2 is 0. In the numerator, you will still have 8 square root 2 minus 16. In the denominator, I'll be left with minus 2, which is minus 4 plus 2 will be minus 2. In the numerator, I have a common factor of 8, so I'm going to take it out. And when I take out a common factor of 8 in the numerator, and obviously if you divide that 8 with negative 2, it's going to give you negative 4. I still have the square root of 2, and over here I do have 2, so in outside so this times this will give me minus 4 square root 2, and minus 4 times minus 2 will give me positive 8, and this is your final answer. classwork. That. In the next video, we're going to do corrections and get into equations with rational exponents.